Hi, this is Albert Nixon, Assistant Professor, Department of Chemistry, St.Joseph's College of Arts and Science, Autonomous, Cuddalore. The topic we are going to discuss about chemical bonding, ionic bonding and covalent bonding. So, ionic bond. The ionic bond is in which atoms have the ability to transfer or share their valence electrons. Some atom gain and some atom lose electrons to produce noble gas configurations. Conditions for the formation of ionic bonding: two electrons must be an opposite charge. One should carry a positive charge, another should carry a negative charge. So one atom belongs to S black element, another atom should belongs to B black elements. An atom or element must have its less ionization enthalpy, that is cation. Another element or atom must have high negative electron gain enthalpy, that is anion. The electronegativity difference between these two elements equal to 1.7. High lattice energy of compound is formed. This is the simplest representation of formation of ionic bonding. Here I am take sodium chloride crystal. So sodium is belongs to S black element. The chlorine is belongs to B black element. Above one should carry positive charge, another should carry negative charge. The sodium atomic number is 11. The electronic configurations of sodium is 1s2, 2s2, 2p6 and 3s1. In the outermost electron, the valence shell contain one electron. In the case of chlorine, atomic number is 17. The electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. There are 7 electrons in the outermost. So sodium is ready to give one electron to attain its noble gas configurations. Chlorine is receive that electron to ready to attain the noble gas configurations to produce ionic bond. Here the simplest representation is given. Some general properties of ionic bonds. Ionic bonds have the ability to remain in a solid state when they are at room temperature. So usually ionic bond is solid at a room temperature. Their structure is crystalline or transparent. They have high melting and boiling point. So if it is an solid, it has melting point. If it is an liquid, it has boiling points, right? But high melting and boiling points. Their bond results in formation of the interaction between the metals of group 1, group 2 and non-metals of group 6 and 7. They are quite strong and depend entirely on ions. They are soluble in water and also they are excellent conductors of electricity when found in aqueous solutions. Usually in aqueous solution they are good conductors of electricity. When they are in solid state, they are not able to conduct any type of electricity. Only the aqueous medium they can conduct electricity. In the solid medium, it cannot conduct electricity. Next one is covalent bonding. So covalent bonding, the mutual sharing of electrons. One atom is giving one electron to attain the stable stage. Another one atom is given one electron to attain the stable state. So Lewis, an American chemist, suggested that there are atoms which can combine with each other or other atoms by sharing the unpaired electrons in the outermost shell. The paired electrons are shared by both the atoms and circulate about the nuclei of both atoms. The chemical bond between two atoms in which the electrons are shared by both the participating atom is called covalent bond. Here I am representing the hydrogen molecule, right? So one hydrogen atom, the hydrogen atom is atomic number is 1. There will be electronic configuration is 1s1. So it attains the noble gas configurations is 2. So one nitrogen is giving one electrons, another one electron atom is giving one electron to form a covalent bond. So usually the B block elements forming the covalent bond. Then for example the C2, F2, these are all exhibiting covalent bond. You take an example of F2. So F2, the atomic number is fluorine is 9. The electronic configurations of fluorine is 1s2, 2s2, 2p5, 9. So totally 7 electron in the outer shell. Another fluorine having also 7 electron in the outer shells. So each one giving 1 electron to form covalent bond. Conditions for formation of covalent bond: combining the atoms have to be short by 1 and 2 or 3 electrons in their valence shell in the comparison to stable noble gas configurations. The electronegativity between two atoms should be 0 or very very small. An approach of atoms towards one another should be accompanied by the decreasing of energy. Some characteristics of covalent compounds. Covalent compounds usually have low melting points. An exception to this include molecule of silica and diamonds have high melting points. So usually all the covalent compounds having low melting. These two are exceptional case, diamond and silica. These are exhibiting high melting point. Then second one is these compounds have low melting points. These can attributed in their weak van der Waals forces. Then third one is these compounds are usually gases and liquids with their low boiling and melting point. Usually the covalent compounds are low melting and boiling points. The solid covalent compounds have soft structure like graphites. This is because of the presence of cloud of electrons between each layer of carbon atoms. These compounds are non-conductors of electrical charge. The absence of charged ions in the main reason behind this. An exception to this, graphite. So graphite is it is a good conductors. Usually the covalent compounds are non-conductors. Graphite is an exception case. They are bad conductors of heat also. Their molecule lack of free electrons and that obstruct the flow of heat energy. Covalent compounds do not possess polar characteristics as a general property. Therefore, these compounds are insoluble in water. Thank you for your patient listening.